Hello students, let's talk about correlation and linear regression in Jamovi, shall we? So here's Jamovi, right? Our old friend Jamovi. Let's create a little data set real quick. Let's call this column, I'm gonna call this column person. It's gonna be nominal, yep. And column B, I'm gonna call height. I'll call age, whatever. This is gonna be continuous. And then the other one can be height. And it's gonna be continuous because it's gonna have a number, right? So let's create some fictitious data real quick. Let's call Bobby. Let's say he is 18 years old and he is 72 inches tall. He's 6 feet tall. Let's call this next person Louisa. Oops, that's not how you spell it, Louisa. And she is 17, let's say she's 5'10", which is 70 inches tall, right? Let's think of someone else. How about Chuck? Chuck, let's say, is 14 years old, and he is, I don't know, 5'6" would be 65 inches. And feet, right, 5'6" feet. Next person, let's say, is Henry, and Henry is 13 years old, and he is a solid 5'3", 63 inches tall. The last person is Earl. Let's say I have too many men there. Let's get a woman here. Let's say, I'm having a hard time with this, a woman's name. Lisa's 11 and she is, let's say she's 61, 5'1" in feet. Good, so I have some fictitious data here we just created. I have two variables that are continuous, right, of continuous data type. That's important to remember what data type you're dealing with. And to get the correlation between these two, it's super easy. But the first thing I'll do before that is to get a little plot. Let's get a plot. I'm gonna come over here to exploration, right here in the top left of my screen, right, and click on exploration and then scatter plot right there. You use a scatter plot when you have two continuous variables. So I'll do that. I'm gonna grab age and put it as the x-axis and height as the y-axis. And that's good. And then you can see here on the right side of my screen, I have age on the x-axis and height on the y-axis. And there's a very almost linear, I made it 2 even. I made my fictitious data 2 linear. If on the left-hand side of my screen we click on linear, it'll put in a regression line, what's called a regression line. And you can see, yeah, the more age, the more height. The more is what we have there. Good, so to do correlation, you click on regression, the fourth from left icon there on the banner up there. I'm clicking, circling it. And then the first option is correlation matrix. I just click that. And then it brings up this other menu on the left-hand side. I drag both of those continuous variables to the right, from the left box to the right box. I just did that. You can either drag or use that arrow. Good. And then it does a Pearson R correlation test down here in the bottom part of my screen. Let me move this up. A Pearson R correlation test between height, right here, this row is height, and then this column is age. And the Pearson R correlation test is 0.995, and the p-value is below 0.001. And that means it's a really strong value. So if we just simply come over to let me get a web browser up over here, and let me just say Pearson R correlation labels. And this page is pretty standard. So this page is saying that if the value is above, let's actually go into it here. This is Newcastle University in the UK. I just want to look at the labels here. They're saying that there's a strong positive correlation. Let me zoom in a lot here. Let me double check you're seeing what I'm seeing here. Yeah. So what they're saying is that if it's between 0.8 and 1, then there's a strong positive correlation, and that's what we have here. We have this one because 0.995 falls within this range. So we would use the word strong. There's a strong correlation, and it's positive because we have 0.995 there, and it's statistically significant with that p-value. Good. I will say that if you have non-normally distributed data points, then you should use one of the other two tests here on the left-hand side. There are two other tests. I usually go with the Kendall's tau, And I bet the Kindle's tau would tell us the same thing. Yeah, the Kindle's tau is saying these are super correlated. That p-value right there is low as well. Okay, so that's correlation, pretty simple. It's only just a monofactorial, just one variable to the other variable. Let's look at a bigger use case scenario. You'll need to go to Canvas and get a data set that is called, let me bring it up over here on the screen you're looking at. It is called 10 LDT correct RT freak length .xlsx Excel file. All right, so that is the data set you can grab from our CMS and Canvas. And this is data from my colleague Jeff, who studies Russian and does a lot of experimental design with his research and has a lot of data sets that deal with reaction time in milliseconds. So column B here is reaction time in milliseconds that native Russian speakers took to react to this word, and it was a lexical decision task. That's what the LDT in the file name refers to. They just simply decide whether it was a word or not, yes or no, and the amount of time they took is noted right there. And then we have two other variables here. In column C, we have the log form frequency. So what is the frequency of this word form? It's a log transformed value. And so that's why it's much lower than what the raw frequency is. And then here, column D, we have form length, and this is the length of the form in, I think it's just orthographic letters, maybe phonemes. I think it's just simply orthography. I don't know Russian, so I'm not sure if some of these letters are silent or not. But anyway, it's the word form. I believe it's in orthography. So we have a continuous dependent variable, RT, which is reaction time. We have two, they happen to be continuous independent variables here. And so we want to do what's called linear regression now. So I'm going to jump back over to Jamovi. Going to go up to the three horizontal bars there in the top left of my screen where I'm circling. Click on the three horizontal bars, go down to open. Click on browse. Well, it's sitting right there already, but if you don't have it sitting there, you would click on browse, and then you would find it on your hard drive. Open it up in Jamovi. And then put it up in this view over here. Let me pull it over here. So there it is. There's our data frame, our data set we just saw in Excel a second ago. Here it is in Jamovi. Good. I'll just jump to the bottom with Control, actually Command on Mac. On Mac, it's Command down arrow. On Windows, it would be Control down arrow. And I have 1,525 rows. I see that number right there at the bottom of my screen. Good. So let's go ahead and do linear regression, and we're going to click on regression again, this same button, the fourth from left button there on the top of my screen, this ribbon. Click on that, and then the third option down is linear regression in that menu, linear regression right there. And then we are going to create our model. I'm going to drag, you can either drag or use the right arrow, right? I'm going to drag RT over to the dependent variables and let go. Then I'm going to grab each of these and move them over. Now I see that it's misidentifying form length as a nominal variable. That's why that icon looks like it's three different circles. It's misidentifying as a nominal variable. I don't think it's going to make a difference. If I just drag it over, it'll probably still work, but for good measure, I'll come over here and change that. So I clicked on data at the top of my screen. I was over here in analysis and I clicked on data. I'm going to double click on the column heading for form, len. I'm going to change the measure type from nominal to continuous, just for good measure, and then slide that back up. I'll go to analysis. Let me get back to that point. Linear regression here, regression, linear regression. I'm going to slide RT over there. And then I'm going to slide each of these into the covariate box. Just going to drag them over like that. Covariate is an independent variable that is continuous. An independent variable that is categorical would go under factors right there. And these icons right there kind of show you that that's what it expects to happen. The icon of the ruler right there where I'm circling with my cursor, right, means that covariates are independent variables that are continuous in data type. And then the factors are nominal data type, independent variables. Okay, so on the right-hand side of my screen now, I have the report, this report window. And what do I see here? Well, I see first I have model fit measures. I have R and R squared. Again, R squared, that value right there, that I'm circling with my cursor right now is how much of the variability in the dependent variable is accounted for by the independent variables. Did I say that right? Let me just restart that again. The R-squared value tells you how much of the variability in the dependent variable, in this case reaction time, is accounted for by the independent variables in the model. In this case, I only have two. I have frequency and length of the word. So this is saying that the way you read this, it's a decimal number, or a float if you recognize that from computer programming language. What this means is that this is gives you a percentage, but you have to move the decimal point to the right. So if I move the decimal point to the right, I have just over 1% of the variability in reaction time is accounted for with these two independent variables, frequency and length of word. So not much, hardly at all. And it does say that there, so I'm looking at the p-value now where my, let me zoom in a bit if I can zoom in. Let me zoom in to make this a little bit bigger for us. If I go here and go like this, make this a lot bigger for us. Maybe that's too big now. That's a little too big. Let me just pull that back a little bit. Okay, so on the right hand side of my screen, right, I'm looking at the p-value right here where I'm circling with my cursor. And it's saying that the log form frequency, freq, is significant. It exerts a significant effect on word length, or excuse me, reaction time. And that's what that p-value there, it says below 0.001. And the estimate value here, negative 43.5, that negative number means that for each unit increase of frequency, there is on average a 43.5 millisecond decrease in the reaction time, is what that number right there means. And so this has a negative correlation or negative relationship with reaction time. So as frequency increases, reaction time decreases. That's what that means with that negative coefficient there. And again, the actual unit of measurement, the way to read that is for each unit increase in frequency, there is a 43.5 millisecond decrease in reaction time on average. And then the form length is not significant. Looking at that p-value is above 0.05. Some people would call this marginally significant. Okay, so that is when you use two main effects. These are called main effects. You can also put in the interaction. Let me do that. So if you come down here on the left-hand side of my screen and you click on Model Builder, this little bar Model Builder to expose this menu, and you click on both. I'm going to use my shift on my keyboard and then click the other one so I have both selected at once. They're on the left-hand side of my screen in blue. And then the second arrow down here, the second box at the bottom, has an interaction term. It says interaction right there. So I'm going to click on interaction, and it adds an interaction term to my model. Right there. The bottom, I'm circling with my cursor on the bottom right of my screen. And so it says log form freq asterisk form len, and then it gives me the values. And so now you may see, wait, we just lost significance from frequency. Yeah, we did. So none of these reach our 0.05 cutoff for statistical significance in linguistics, at least, right? Where 0.05 is the standard cutoff for rejecting the null hypothesis and accepting the alternative hypothesis. So yeah, what it shows to me, the fact that we lost that, is that there is probably some interaction and there's a lot of other things that are going into reaction time here. If we look up here at the top part of the right side of my screen where I'm circling right now, the R-squared is still just barely above 1%. If I move that decimal point 2 spots to the right to end up with a percentage, I would end up with 1.25% of the variability in reaction time is accounted for by the independent variables down here, the three that I have now. I have frequency and word length and the interaction between those two. So there's many other variables, many other causes for reaction time to vary in this data set that we're not accounting for. So the take-home message is that there's probably other variables that are more important than these, perhaps in interaction with these, but we need some other variables to try and account for reaction time in this data set. So there you have it. You can do correlation and linear regression with this button right here called regression in Jamovi. It's the fourth from left, or fourth from left one right here on my display called regression. You have correlation matrix and linear regression right there. Okay, so that brings us to an end of this quick video. Hope that went well for you. See ya.